characteristics of a chemical equation, what are the conditions necessary, or what are the types of chemical equation and all. Okay, so today we will have a very important topic, that is how we will write a chemical equation. From the starting class only I was saying that at the end of this chapter we will have this topic, that is how you can write and balance a chemical equation. So today we will have this topic. Just listen to it carefully, and those who are not having with your copy, note copy and pen, please just be with your notebook and pen, so that while I am discussing you can also write it by your own. Okay, by doing that you will have a more clear idea about the topic. Okay, so let us start the topic. Here, chemical equation. What do you mean by a chemical equation? Chemical equation means whenever a chemical reaction is represented in its symbolic form, we call it as chemical equation. Means already we have discussed when two reactants they come closer to each other, they will change their electronic configuration and they will form a new product. This process is known as what? Chemical reaction. So when this chemical reaction is written in a format or is written in such a format that we will represent the reactants and products in their symbols and formulas, that is known as chemical equation. Okay, so before making or before writing a chemical equation, first we will write the word equation. What is word equation? When we will write only names. For example, if I will say hydrogen and oxygen, they will react with each other to form water. So when I will write hydrogen plus oxygen gives rise to, means arrow, water, this is a word equation. But if I will write 2H2 plus O2 gives rise to 2H2O, this is the chemical equation. Okay, so at first let us discuss what all are the rules to write a chemical equation. Okay, so all the rules should be satisfied so that at last we will get a balanced equation. Got it? So here let's start the topic with the first rule. The first rule to write the chemical equation or the word equation is that the reactants should be written on the left hand side and the product should be written on the right hand side. Okay, whenever we are talking about a chemical reaction involves both reactants and product, is it? So the reactants should always be written on the left hand side and the products should always be written on the left hand side. Okay, so here when we are writing reactants, reactants should be in the left hand side. Okay, just I am writing R and P. Okay, reactant should be on the left hand side, arrow will be given in between, and product should be in the right hand side. Got it? This is the first rule to write an equation. It may be a word equation, it may be a chemical equation. To write an equation or when we will represent a chemical reaction, like this we will represent. We will keep the reactants on one side and we will keep the products in another side. The reactants always should be kept in the left hand side LHS and the products should always be kept towards the right hand side, that is the RHS. Okay, so this is the first rule. What is the second rule? If there is an involvement of more than one reactants or products, that reactants and products should be separated by plus sign. Okay, should be separated by plus sign. Okay, this all thing you remember. Got it? So here let me write reactant 1 plus reactant 2. They will form product 1 and product 2. See here, there is an involvement of more than one reactant and more than one product. So whenever we will get more than one reactant or whenever there is an involvement of more than one reactant, we have to separate the reactants. These are some common things that you know already, I think. That reactant should be separated by plus sign, and whenever we are getting more than one products, that product should be separated by plus sign. Okay. Next, the third one is conditions necessary for reactions should be written above or below the arrow mark. So this is the arrow mark, you can see. The condition necessary like heat, cold, electricity, okay, pressure, this all condition, or heat or light. Already we have discussed what are the conditions necessary for a chemical reaction. That conditions should be written above or below the arrow mark. Okay. Suppose reactants gives rise to product. So here the conditions, any of the conditions like light, okay, or heat, that will be if light and pressure both are needed, then we can write pressure. Okay, you might have observed while we are writing the equation for photosynthesis, we are writing the what condition, that is the sunlight and chlorophyll at the top and below of the arrow mark, is it? So what we are writing, this side we are writing the reactants, and just over and down to the arrow mark we are writing sunlight, and down we are writing chlorophyll. Okay, so whichever condition necessary that are needed to be that are written on the top or below the arrow mark. Okay, we cannot write it towards the reactant side, or we cannot write it towards the product side. Okay. Next, name of the reactants and products are replaced with symbols and formulas to get the chemical equation. After this, we are discussing about at first, whenever here we will discuss some example, there we will have more clear idea. So when at first we are when we will write an equation for a chemical reaction, at first we are writing the word equation. Okay, so as I said, formation of water, if I will tell you write the equation for formation of water, so at first we will start with the word equation, hydrogen plus oxygen, arrow, water. Then you have to replace that names with symbols. This one only it is given. So whenever we are writing a word equation, that word equation or the reactants and the products of the word equation should be converted or should be replaced with their symbol. Then only we can get the chemical equation for it. Okay. For example, the same example I am giving, hydrogen plus oxygen gives rise to water. Okay, so this is the general word equation to represent the reaction between hydrogen and oxygen to form water. So here the reaction is not completed because we have to replace the names with their symbols or formulas. Okay, so here what we can write, H2 plus O2 gives rise to, so this is the exact equation for the reaction of hydrogen and oxygen. So whenever we are writing the equation, at first we have to write the word equation, then below that word equation we will replace that names with their symbols or formulas to make it a chemical equation. Okay. Next, reactants and products must be written as molecules, not as atoms. We cannot write the reactants and products in their atom format. We have to write their molecular format. Like the same example here I am repeating. Suppose here I will write H plus O, or okay, here suppose I will write H plus O gives rise to H2O. Means here you can see I have not written their molecular format, I have written their what, atomic format. So here we cannot write only the atom, or we cannot represent the reactants or products basing on their atoms. We have to write their molecules, like, okay, we have to write their molecules. Again, it is not balanced, that one I will discuss in the next one. Okay, here just remember, whenever we are writing a chemical equation or word equation, I mean not word equation, whenever we are writing a chemical equation means we have to write the molecules of the reactants and products. We cannot write the symbols, or we cannot write the atoms. Okay, we cannot write the symbol in atomic format. We have to write their symbols in molecular format. Okay, so here, or else one more example I can give you. Mg plus O gives rise to MgO. We cannot write this O here. We have written it in what? Atomic format. So it is wrong. Got it? So while gradually you will do some more chemical equation by your own, by that you will have a clear idea for this. So this is the next one, that is we have to write it in its molecular format. The last rule is the number of atoms on the both sides should be equal. Okay, then only the equation is balanced. So whenever we are writing an equation, whenever we are writing a chemical equation, that equation should be a balanced equation, or else that is an incorrect equation. Okay, so whenever we want to write a correct chemical equation, then we have to balance both the side. Okay, both the RHS means both the LHS means the left hand side and the RHS right hand side should be balanced, so that we will get a balanced chemical equation. Okay, so here for this here I am given C, H2 plus O2 gives rise to H2O. Okay, here if I will write the equation for water, hydrogen plus oxygen, here I have written both in its molecular format. Okay, hydrogen plus oxygen gives rise to water, H2 plus O2 gives rise to water. We can see now how many hydrogen towards the left hand side, towards the, this is the LHS, this is the RHS. Okay, how many hydrogen towards the left hand side? 2. Number of hydrogen is 2. How many hydrogen towards the right hand side? The same 2. It is correct. How many oxygen towards the left hand side? 2. How many oxygen towards the right hand side? 1. Means this is a wrong chemical equation. We have to balance. Here the number of atoms present in left hand side should be equal to the number of atoms present towards the right hand side. So here we can balance it. How we can balance? Here we will add 2. Okay, if here we will add 2, then we can have 2H2O. Means the number of oxygen here we are getting 2 again. Now again see number of hydrogen. Here the number of hydrogen is 2, but here what is the number of hydrogen? 4. Okay, 2H2 means the number of hydrogen is 4. Again we have to balance. So what we can do? We can add 2 here. Okay, now we can check whether it is both the side. Now it is equal or not. Hydrogen 4, oxygen 2. Hydrogen 4, oxygen 2. Got it? See, whenever we are writing 2H2 means 2 molecule of hydrogen. 2H2O means 2 molecule of oxygen. Like this, if we will write, then it represents 2 molecules of oxygen. Okay, or 2 molecules of water. Okay, so here 2H2O means 2 molecules of water. Okay, so when here we will balance the equation, we will get this equation. This is the correct equation. So what we can write, or what we can say, when 2 molecules of hydrogen reacts with a molecule of water and oxygen, it forms 2 molecules of water. Again I am repeating, when 2 molecules of hydrogen balance both the sides. Got it? So these are the rules that are involved while writing a chemical equation. Okay. So again, in short I am repeating, the reactant should be in the left hand side, the product should be towards the right hand side. Whenever we are having or whenever a chemical reaction is having more than one reactants or products, they are needed to be separated by a plus sign. The reactants and products, if they undergo reaction in some condition, then that conditions should be written just above or below the arrow mark. Next, the reactants and the products are replaced. They should be replaced with their symbols and formulas to convert the word equation to chemical equation. Next, both the side of a chemical equation should have balanced number or equal number of atoms. Okay, the number of atoms present towards the left hand side should be equal to the number of atoms present towards the right hand side. So we should always check whether the number of atoms are equal or not. Next, we have to balance the last one is we have to balance both the side of the equation, and here I have given some example. So let us discuss some more example, then you will have a clear idea of the topic. Only I am discussing some few more, we will discuss gradually, we will discuss in your book also. Some more examples are there. By your own you try to solve more chemical equation. I will also give you some more chemical equations to solve. Okay, so let us discuss some examples. Burning of carbon. Okay, first example, burning of carbon. So whenever we are talking about burning of carbon, in the presence of what burning takes place? Oxygen. Oxygen supports burning. So here we will write the equation for carbon and oxygen. What happens when carbon burns? Okay, so at first we will write the word equation. Remember, as you are the beginners for writing the chemical equation, at first you write the word equation, then convert the word equation to chemical equation. It will be easy for you. Okay, so here I am writing burning of carbon. Here I am writing carbon plus oxygen combines to form carbon dioxide. Carbon plus oxygen combines to form carbon dioxide. Okay, this is the general general word equation for the burning of carbon. Now we will convert that word equation into chemical equation. Okay, so carbon plus oxygen gives rise to carbon dioxide. So here let us check whether the number is same or not. Number of carbon 1, number of carbon here 1, number of oxygen 2, number of oxygen here. So here this equation is already balanced. Got it? So here we got already a balanced equation. So like this we have to write some equations. Sometimes we got in balanced format also. If sometimes we are not getting, then we can write it in their balanced format. Okay. So the next example let us discuss. The next one is heating potassium chloride. What we will get the product when we will heat potassium chloride. Okay. So we can write the word equation at first. Potassium chloride, when it is heated, as I said, the conditions should be written on the top or below the arrow mark. Okay, we will get potassium chloride plus oxygen. Got it? So we can write the chemical equation for this. KClO3 will be the formula for potassium chloride. When it is supplied with heat, it can form KCl plus O2. Okay, this is the formula for potassium chloride. Potassium chloride, when it is supplied with heat, it forms potassium chloride and oxygen. Now we can balance it whether it is balanced Potassium, number of potassium 1. This side also 1. Number of chlorine 1. This side also we got number of chlorine 1. Number of oxygen, this side we got 3, but this side the number of oxygen is 2. That's why we have to balance. Okay, it is not balanced. See, the unbalanced equations are also known as skeletal equations. Okay, sometimes we will get this term. So we have to reform that skeletal equations into balanced equation. So here, if we will add 2 here. Okay, now how many oxygen we got? 6. Okay, we got now 6 oxygen. But with that again here we got 2 potassium and 2 chlorine. So again we have to add 2 here. 2 potassium and 2 chlorine. Here we got what? 6. 6 oxygen. That's why here we will add 3. Got it? Now let us check. 2 potassium, 2 chlorine, 6 oxygen. 2 potassium, 2 chlorine, 6 oxygen. Got it? So this is the balanced equation. Like this you have to balance the equation and just check it number of times, because as you are doing for the first time you may have mistakes. So check the equations number of times, just see. And this one already I have discussed. If we will write down what it means and here we will write then what it means. 2 KClO3 means 2 molecules of KClO3. 3O2 means 3 molecules of oxygen. Got it? Here if I will write that part already we have discussed, so I am not again going to that part. What it represents when we are writing is at a subscript or when we are writing before the formula. Okay, so this is the equation how you have to balance it. Let us move on to the next example. Got it? Next, reaction of hydrogen and chlorine. Okay, we can write hydrogen plus chlorine, they will form hydrogen chloride. Hydrogen and chlorine, when they will react with each other, they will form hydrogen chloride. So we can write the chemical equation for this. Hydrogen and chlorine, when they will react with each other, they will form hydrogen chloride. So this is a chemical equation for the formation of hydrogen chloride. Now by your own you just try to balance it. Okay, I am here balancing. You also try to balance. Hydrogen 2, this side hydrogen 1, oxygen 2, chlorine 2 and chlorine 1. So what we have to do? We have to balance both the side. H2 plus Cl2 gives rise to 2HCl. Okay, if we will add 2 here, then we can have balance, because 2 hydrogen and 2 chlorine this side also. Got it? So this is how we have to balance a chemical equation. This is how we have to write and balance a chemical equation. Got it? So again you have to repeat it number of times, or else you will have confusion on this topic. Okay, so it's my suggestion to have to practice how to write a chemical equation. And you might have thinking that, madam, how we can know that by the reaction of hydrogen and chlorine, hydrogen chloride will only form? That you will learn gradually when you will learn more about chemical reaction. Gradually when we go to higher class, by learning different chemical reactions, you can find that by the reaction of which reactants, which products will form. Okay, you have to learn that reactions. Okay, so for that you have to practice more. Now as you are just beginning this topic, you will get simple equations. Gradually when you will move on to 8th, 9th or 10th class, then there we will have some more complicated equation. Okay, and that time you can also solve it if you will practice these equations in a very proper way. Got it? So this is all about our today's discussion. Again go through the topic. Again I will give you some more homeworks. Okay, some more equations to find out, to solve that equations. Okay, so to solve that equation and if you are getting any doubt, then you can ask me number of times, okay? Because as you are doing it for the first time, obviously you will get more doubts, okay? But do not worry about the doubt. You can ask me, you can find out the solution of your doubt and practice it number of times, okay? So till then, just keep on